you've had a bit of time to look through this, and someone's just asked a question about the differences between all of these. Yeah. This first one is just picking a single chocolate and looking at its weight. The one down here is picking the 25 chocolates that make a box, finding the average weight of those 25 chocolates and seeing if that average is between these two values. The middle one is summing things together. And those are the three possible scenarios that we can get. So part A is nothing to do with the central limit theorem at all. Part A is just a normal probability question. So if we look at our part A, we've got W. It's normally distributed 10, and I'm going to write it as 2 squared this time rather than 4, because that gives you my standard deviation. And I want the probability that W lies between 9.5 and 10.5, and this time it really doesn't matter whether you put extra bars on there, really principle. I'm going to do a sketch. I want that shaded area. Anybody, any comments?
You can do 10.5 to 10 and then double it.
I could do 10.5 to 10 and double it.
X is less than 9.5 and then do 1 minus that.
X is less than 9.5, 1 minus that. That will give me everything you can see on the right.
And then minus the 9.5 value.
We're getting there. I think you're on the right lines, yeah. What we want, the shaded bit, is everything take away 2 unshaded bits, and the unshaded bits are equal because of the symmetry here, because this limit is the equal distance below the 10, but this limit is above the 10. By symmetry, the easiest way of doing that is saying it's 1 take away 2 white bits, which isn't what you write down in the exam. Okay, basically if you take 2 white bits away you get what you want, so it's 1 minus twice the probability that X is less than
9.5.
9.5, yeah. And then you can just do that as a straightforward normal phi-ing question. So I'm just going to freeze this in the class a minute.
Did you say a negative value is the same as a positive value?
What you should have found is that you're phi-ing a negative.
Yeah.
So you need to do 1 minus phi of the positive.
Oh yeah.
So if you want to look at the board, you'll see that bit is written down if you want to check that bit. If anybody wants to shout out a final answer.
Mine's 1974.
I think it is. Yeah. Okay. I'm just going to pause the video at that point, stop it for another clip.